Hello, and welcome back to Sudoku Swami's pencil and paper method. For the next several lessons, we're going to start out with a short tutorial on various fundamental concepts intended to help all of you who might be new to Sudoku. And today we're going to talk about naked singles. So if you already know how to find naked singles, and more importantly, what creates them, then you can skip ahead to the step-by-step solving of our very first puzzle in this series. Okay, naked singles. First, you may ask, what exactly is a naked single? A naked single occurs when there is only one possibility left for any particular cell as a result of that cell being able to see an instance of all other 8 digits. This means there can only be one possible candidate for that cell, and that's why it is said to be naked. That candidate will be all alone in that cell with no other possibilities, and so of course it will be the solution to that cell. This can happen in 2 ways. One, by way of what's called a natural full house, and 2, by way of what I call a disjointed full house. A regular or natural full house is very easy to understand. Whenever you have 8 of the 9 digits placed in any house, i.e. a row, column, or block, then there can only be one choice left for that last remaining cell. Whichever digit is missing will be the solution to that last cell, i.e. the 9th cell. Here in this diagram, in row 3, we have 1, 3, 4, 5, 6, 7, 8, and 9. So what's missing? The 2. So the 2 has to be the solution to that cell because there has to be a 2 in that row. And it doesn't matter what else is going on in block 2, and it doesn't matter what else is going on in column 6. That 2 has to go in that cell because there has to be a 2 in row 3, so it is the only possible number for that cell. And here in this diagram, in column 5, we have 1, 2, 3, 4, 5, 6, 8, and 9. So this cell has to be a 7. And here in block 5, we have 1, 2, 3, 5, 6, 7, 8, and 9. So this has to be a 4. The house is full except for one cell, hence the name full house. If you were using a computer app with automated candidate lists, this cell would have a single candidate 4 in it, indicating that it is a naked single. But since we are doing the puzzles with pencil and paper, that candidate 4 won't be there, but we'll just know that it is a 4 because that's the only digit left for that house. Okay? A disjointed full house occurs when you have a cell that can see an instance of 8 different digits that are not all located in the same house. Those 8 digits will be spread out in 2 or 3 houses instead of just one house. Like here in this diagram, this yellow cell can see the 1 and the 5 in row 3, it can see 2, 6, 7 in block 1, and it can see 3, 4, 8 in column 3. So we know this has to be a 9. That's the only digit that it cannot see. It can see all 8 of the other digits. And likewise, here in this diagram, this yellow cell can see 1, 2, 4, 5, 6, 7, 8, and 9. So it has to be a 3. And in this diagram, this yellow cell can see 1, 2, 3, 4, 6, 7, 8, and 9. So this has to be a 5. And you can see these digits are in only 2 houses, and there are no extra digits in block 8, but that doesn't matter. It can see all 8 digits except the 5, so that has to be the solution to that cell. Remember, in order for a cell to see another cell, they must both be in the same house. And also remember that every cell in the whole puzzle lies in 3 houses, i.e. a row, a column, and a block. So it can see all the cells in the 3 houses in which it lies, and any 2 cells that can see each other cannot have the same value. So for our first puzzle of this pencil and paper course, I have chosen a fairly easy puzzle that will hopefully demonstrate many of the things we have covered in the last 2 lessons, as well as some naked singles that we just talked about. Now, it's always fun to see how fast we can solve any puzzle, but our objective here today is not speed. So we'll just go slow so I can explain what I'm doing as we go along, okay? And wouldn't you know it, right off the bat, we have a naked single that's the result of a disjointed full house. This cell right here can see a 1, a 2, 3, 4, can't see a 5, but it can see a 6, 7, 8, and 9. So we know this must be a 5. And you can fill it in just like that. All right, now that that's out of the way, let's cycle through the digits starting on 1 and see what we can find. If we look in columns 5 and 6, we see we've got a 1 here and a 1 here. So that blocks these 4 cells, right? And this one blocks this cell. So the only place left for a 1 is right here, and we can fill it in. But let's take a look at that. This cell can actually be a 5, 7, 8, or a 9. It can only see the 4, 3, 6, and a 2, okay? But that doesn't matter. We know that because these green colored ones are blocking those red cells, this can only be a 1, and so we can fill it in. This is called a hidden single because it looks like it could be a 5, 7, 8, or 9, but we know that it cannot be because these ones are blocking those 5 red cells. All right, now these 2 ones block rows 2 and 3, and there's a 1 down here in column 8, so we can enter a conjugate pair into these 2 cells. One of those 2 cells has to be a 1. All right, next, these 3 ones are blocking these cells down here in block 7, so that means the only cell left where a 1 can go in this block is right there. And you can fill it in just like that. Now let's go back. Notice that this cell can also be a 4, a 6, or a 7 because it does not see a cell containing any one of those digits. But we know because those 3 green ones block those red cells, this can only be a 1, and you can enter it just like that. Now again, this is called a hidden single, and we'll be covering these in the next lesson. All right, next, these 2 green colored ones block these cells here in block 6, and so that means we can enter a conjugate pair into these 2 cells. Now I want to point out something that's very interesting. Notice that there is a conjugate pair on 1 up here in row 1, and there's another conjugate pair on 1 down here in row 6, and they line up such that they are both in the same 2 columns. And because of that, these 2 ones in column 7 become a conjugate pair, and the 2 ones in column 9 also become a conjugate pair. And the reason for that is we know that one of these ones up in row 1 has to be true, and one of these ones in row 6 has to be true. And the only way that's going to happen is if these 2 are true and these 2 are false, or the other way around. These 2 are true and these 2 are false. So what that does is it creates an X-wing, because these 4 candidates kind of look like they make an X. Okay? So as soon as we solve any one of those 4 candidate ones, we will immediately know that the one on the diagonal is also true and that you can erase the other 2. All right, so now we've dealt with the 1s in all 9 blocks, so let's move on to the 2s. But I'm not going to use so many colors from now on, otherwise it's going to take 2 hours to go through this puzzle, which can really be solved in about 5 or 10 minutes. So we've got a 2 up here in row 1, we've got a 2 in row 6, and we've got a 2 in column 2. So that blocks all the cells in block 4 except for this cell, and so the 2 has to go there, right? So now this 2 is blocking row 4, and this 2 is blocking row 6, so there's only 1 cell left in this block for a 2 to go, and we can put it in just like that. And this 2 up here in row 1 blocks these 3 cells in block 3, and this 2 we just put in blocks column 8. So we can put a conjugate pair of 2s into those 2 cells. One of those 2 2s must be true. So those 2 candidate 2s block the rest of row 2. And because of this 2 down here in column 4 and this 2 in column 5, there's only 1 place left for a 2 in block 2, and that's right here, and you can fill it in. Then down here, this 2 blocks row 7, and this 2 blocks row 9. So again, we've got another conjugate pair of 2 in row 8. Because again, this 2 is blocking column 8. So now we have another X-wing on 2s. We have an X-wing on the 1s, and we have an X-wing on the 2s. One of those 2 diagonal pairs of 2s is going to be true, and the other 2 are going to be false, even though we don't know which is which. But as soon as we enter one of them, we will know that the other diagonal one is true, and you can erase the other two. Okay, so now we've dealt with the 2's in all 9 blocks, so let's go to the 3's. Up here in row 1, this 3 blocks these 3 cells in block 3. Okay, there can't be a 3 in there, and this 3 down here in column 8 blocks this cell. So just like the 2's, there is a conjugate pair on 3's in these 2 cells. So now that is a naked pair. Now really that is a hidden pair because this cell could be a 4 and a 9, and this cell could be a 4, an 8, or a 9. But because we know the 3's are a conjugate pair and the 2's are a conjugate pair, to us that is a naked pair of 2 and 3. Those 2 cells must be solved for 2 and 3. And now that the 3's are accounted for in row 2, and there's a 3 in column 2 and a 3 in column 3, there's only one cell left for a 3 in block 1, and that's right there. And now there's something interesting going on down here in the lowest horizontal chute. This 3 is blocking all of row 7. And 2, 4, and 1 are blocking these 3 cells here in block 8. So the only place a 3 can go in block 8 is in these 3 cells, right? So that means there cannot be a 3 in either of these cells, and there cannot be a 3 in either of these cells, so this must be a 3. That is another hidden single. And now that we've entered that 3, look what happened to our naked pair up here. This cell can no longer be a 3, and as you can see, it's been automatically erased. But you're going to have to take your eraser and erase that 3, and now you can enter this 2. So what this does is now we know the other diagonal 2 is going to be true because that was an X-wing. So that 2 is true. And now because this was a naked pair, if this cell is 2, this cell must be 3. Okay? And now to finish off the 3's, we can enter a conjugate pair here and a conjugate pair here. That is another X-wing on candidate 3. So now let's move to the 4's. We've got a 4 here and a 4 here, so we can enter a conjugate pair like that. And this 4 blocks the rest of row 1, so there's only one cell left in this block for a 4, and it must go there, which means that this must be a 4 over here, because we already have a 4 in row 1, and now we have a 4 in row 2, so there's only one place left for that 4 in block 1. So now this 4 is blocking all of column 3, and this 4 is blocking all of row 9, which leaves only one place left in this block for a 4, and you can put it in. Now notice this 5 down here in row 9. There cannot be a 5 in any one of these 3 cells. That leaves only one place left to put a 5. Now we have a conjugate pair on 5 in these 2 cells. Well, let's go back to the 4's. Did we finish the 4's? Let's see, 4, 4, 4. Okay, we've got a conjugate pair on 4 in these 2 cells because of these 2 4's in row 8 and row 9. And now, because of this 4 in column 3 and this 4 in column 2, there must be a 4 in this cell. So now that blocks row 6. And because there's a 4 up here, we can put a conjugate pair into these 2 cells. Now notice, one of these 2 4's has to be true, which means this 4 cannot be true. Remember, we had a conjugate pair vertically on these 2 4's. So one of these 2 4's has to be true. So you can erase that 4, which means this 4 has to be the solution to that cell because one of those 2 4's had to be true. So you can enter that. Now we know that this is going to be a 3 and the other diagonal 3 is going to be true, and you can erase all those other candidate 4's and 3's. So now it looks like the 2's are done. 2, 2, 2, 2, 2, 2, 2, 2, 2, and it looks like the 3's are done. 3, 3, 3, 3, 3, 3, and 3, 3, 3. So all the 2's and 3's are done, and on the 1's we have 7 of them placed plus this X-wing in row 1 and in row 6, and we have 7 of the 4's placed with an X-wing in row 4 and row 7. But before we go back to the 5's, I would like to point out that there is a naked single in this yellow cell by virtue of a disjointed full house. This cell can see a 1, 2, 3, 4, 5, and it cannot see a 6, but it can see a 7, 8, and 9. So the only thing left for this cell is a 6, and we could fill it in, but I don't want to do that right now. Let's go back. Now, a natural full house is always very easy to see, but the disjointed kind is not that easy to see, and I wouldn't spend too much time looking for them unless you are stuck and it looks like a particular unfilled cell can see a lot of numbers like it does here. But let's proceed as if we didn't see that. If you notice, there are exactly 2 unfilled cells in column 1, so we know that's a naked pair, right? we've got 1, 2, 3, 4, 5, 8, and 9. So these two cells have to be 7 and 6, right? But there's a 7 in block 1, so this cell cannot be a 7. It has to be a 6, which means this cell has to be a 7. So now we've got a naked pair in block 7, which means this has to be 6 and 9 and 6 and 9 because they are the only two digits left in row 9, and they are the only two digits left in block 7. And likewise, up here in block 1, the only two digits left are 8 and 9, so we can put those in there as a naked pair. And over here, we've got another two cells missing in row 2, and we could have seen that there's a 5 up here in row 1 and a 5 over here in row 3. So one of these has to be a 5, and this 7 blocks these two cells, so one of these two cells has to be a 7. So that is another naked pair of 7 and 5. And now we've got two cells left in block 2. They must be 8 and 9 because they are the only two digits left. And now to finish off the 5s, we've got a 5 here in column 7 and a 5 here in column 8. So we can enter a conjugate pair on 5 in these two cells. And then we've got two empty cells in row 5, so they must contain a 5 and an 8 naked pair, right? And because there's a 5 in row 8 and a 5 in row 9, there must be a 5 in one of these three cells here in block 8, but we're not going to fill them in because they are not a conjugate pair. So now let's go to the 6s, and we have a 6 in column 4, and we have a 6 in column 6, so that means one of these two cells must be a 6. And then over here in column 8 we have a 6, in column 9 we have a 6, and there's only one place left for a 6. So we can put that 6 in there, and we can fill it in, and so that erases this 6, so you're going to need to use your eraser and erase that 6, and you can fill in that 6. And now this 4 was part of that conjugate pair, remember? So now you can fill that in, and we can fill in the diagonal one, and you're going to have to erase the 4 that was over here. So one of these two cells is a 5, and one of these two cells is a 1. And now back to the 6s. There's a 6 in column 1, and there's a 6 in row 4 and row 5, so we can put a conjugate pair here and here. All right, now let's go to the 7s. In column 7, we have a 7. In column 9, we have a 7. So there's only one space left for a 7 down here in block 9. So we can put that in. And now we have a full house in that block. So this has to be a 9. And then we have another full house in row 8. So this has to be an 8. But now that we put this 8 in, that removes the 8 from this cell. Remember, this was a naked pair of 8 and 9. So we can solve that for 9 and that for 8. You're going to have to erase those other digits. Then this becomes a 5. And that becomes an 8, and this has to be a 5, and therefore this has to be a 6. And now because we entered 8 in this cell, this naked pair up here is solved. That has to be a 9, and that has to be an 8. And so that solves this naked pair down here of 6 and 9. And then when we entered this 5 here in row 5, we see that this must be a 7, and this must be a 5. And we've got a full house over here in block 4, so this has to be a 7. Now because of this 7 here in row 4 and this 7 here in row 5, this must be a 7. And now let's look up here in row 1. Remember we were going to enter triples only when they are 2 by 2 by 2? Well, these three cells must be 1, 8, and 9, right? Because that's what's missing from row 1, and that's what's missing from block 3. But we've got an 8 down here, so this must be 1 and 9. And we've got a 1 down here, so this must be 8 and 9. And we've got a 9 down here, so this must be 1 and 8. So if we solve any one of those candidates, it's going to solve the other two cells because of that 2 by 2 by 2 configuration. So now we had a conjugate pair on 5, but because we entered this 5 down here, we have a lone 5 here, and we can enter that. And we have a naked pair here in row 6 of 1 and 8. So because of this 8 down here, this has to be the 1, and this has to be the 8. And now these cells up here in row 1 are solved for 1, 9, and 8. So now we've just got a bunch of full houses left. In column 8, we have 1, 2, 3, 4, 5, 6. This has to be a 9. And then in row 4, we have 1, 2, 3, 4, 5, 6, 7. This has to be an 8. And then instead of looking at this as a triple, we can look at it as 3 full houses. So let's start in column 6. And we've got 1, 2, 3, 4, 5, 6. This has to be a 7. So the only remaining numbers are 5 and 9, and because of this 5, this has to be a 9, and therefore this is a 5. And there you have it. Okay, that's going to do it for today. In the next lesson, there will be a short tutorial on hidden singles. This is when it looks like there might be several candidates remaining for a cell, but on further inspection we will see that there is really only one choice. And then after that, we will solve another puzzle just like we did today. So I hope to see you then. In the meantime, be well and be happy.